Hello students, yesterday we see the work done and efficiency formula for Pelton wheel. So for solving the problem and design the Pelton turbine, we need some parameters. So let us see the Pelton wheel design. So first thing is velocity of jet, that is equal to V1 equal to CV under root 2GH. So V1 is velocity of jet at inlet, and the terminology CV is coefficient of velocity. So this value is given in the problematic. If not given, we are taking this value, CV value 0.982 to 0.99, and H equal to net head of water. And the second parameter, velocity of wheel, U equal to KU root 2GH, or in the some other textbooks its value is pi root 2GH, where KU or pi equal to speed ratio. So its value about 0.43 to 0.45, and as usual H equal to net head. Another important parameter is angle of deflection. So it reflects the, so when the jet of water strikes the bucket, it will be deflected. So as like, so this deflection is measured from parallel axis x. If let us, this is x axis, so we measure the angle from x axis to how much it deflected. This is the angle of deflection. So in the problematic, in that there is no angle of deflection given, we consider 165 degrees. And the another thing is mean diameter of runner or wheel. So as you know already, peripheral velocity of runner formula U equal to pi dn by 60. So from that d value, d equal to U into 60 by pi n, where n is the speed of runner in RPM. Jet ratio. So jet ratio is the ratio of diameter of runner, that means pitch diameter of runner by jet diameter or nozzle diameter. So in the entire water turbine, we consider only pitch diameter of the runner. So this value should be taken about 12 for the design purpose. So in the process, so to find the number of buckets which are arranged over the runner, so after calculating the diameter of runner, we need to arrange the buckets, number of buckets in equal distance over the runner. So to calculate this number of buckets, there is one problem. There is one formula, that is Z equal to 15 plus capital D by 2D, where capital D is the diameter of runner and small d is the nozzle diameter or jet diameter. And next thing is seventh one, number of jets. So to produce the high kinetic energy, we need to arrange more than one jet. We need to arrange more than one nozzle. So to calculate the number of jets, there is one formula, that is total discharge through the turbine by discharge of jet through single nozzle. That means మొత్తం discharge, whatever release the total discharge by discharge of jet through single nozzle. సో ఒక సింగిల్ nozzle నుంచి ఎంత discharge అయితే వస్తుందో that is put in denominator. And next thing, design of bucket dimensions. So that means we need to calculate length, breadth and thickness of bucket. So this length, breadth and thickness of bucket in terms of multiply of diameter of jet. So the formula is here. Width of the bucket is 3 to 4d and length of the bucket is 2 to 3d and thickness of bucket is 0.8 to 1.2d. So now see the one problem. This is the simple problem on Pelton wheel. So a Pelton wheel operates under a head of 150 meters. So immediately we write the given data. So net head h equal to 150 meters and diameter of jet is 50 mm. Jet diameter, that is d, small d, is 50 mm. So we need to convert this 50 mm into meters, that is 0.05 meters. How? We know 1 meter equal to 1000 mm. So we can also this 1000 into 1 mm. So 1 mm equal to, send this 1000 to left side, so thereby this 1000 is denominator, comes in denominator. That means 1 mm equal to 1 by 1000 meter or 10 power minus 3 meter. So here I will do 50 into 10 power minus 3 meters. That means 0.05 meters. Next, speed ratio 0.45, that is pi equal to speed ratio. Pi is equal to 0.45. Next given data is jet is deflected through 160 degrees. So deflection angle 160 degrees. So here we need to calculate the outlet blade angle. That is pi. The pi formula is 180 minus deflection angle. So 180 minus 160, 20 degrees. So next given data is neglecting friction and other losses, estimate the output and efficiency. So that means we need to calculate output, that means that is power developed. And another one is efficiency. So as we know, what is the formula to calculate the power developed? That is P is equal to power developed means work done per second. That means that is rho A V1 formula. Rho A V1 minus U 1 plus cos pi into U watts. So we know the density of water rho, and A, where A is, we need to calculate A. So A is the area of jet, that is equal to pi by 4 small d square. So pi by 4 small d, jet diameter is 50 mm. So we convert this 50 mm meters, that is 0.05 square. So value is 1.963 into 10 power minus 3 meter square. We calculate the area of jet A. So we need to calculate V1 value and U value, cos pi value. Pi value we already know, 20 degrees. So we need to calculate V1 value and U value. So let us calculate V1 value. So V1 equal to velocity of jet at inlet, that is equal to CV root 2G capital H. So V1 is equal to CV. What is the value of CV? Here 0.97. So 0.97 under root 2 into G value 9.81 and H value net head 150 meters. So after calculating this value, we get jet velocity 52.62 meter per second. And next thing is small u, that is peripheral velocity of runner. So formula is pi root 2G H. So pi is so in the question there is no value given, pi. So consider pi speed ratio is 0.45 for the designing purpose. So this is the assume 0.45 2 into 9.81 into 150. So its value is 24.41 meter per second. So substitute these values, substitute all the values in the power developed formula. So first one, power developed in the Pelton turbine, that is equal to rho A V1 minus U 1 plus cos pi into U in watts. So what is the density of water? That is 1000. And area of jet, that is 1.963 into 10 power minus 3 1.963 into 10 power minus 3. Hmm. 1.963 into 10 power 3 and V1. So this is the V1 value, 52.62. V1 again 52.62 minus U value. This is the U value, 24.41 into 1 plus cos 20 degrees into U value 24.41. So by calculating this entire expression, we get 137967 watts approximately. So by converting this watts into kilowatts, that means kilo means 1000. So 1 2 3. So we put the decimal value after 7, 96 kilowatts. This is the final answer. And the next thing, we need to calculate efficiency, that is hydraulic efficiency. Hydraulic efficiency formula is 2 into V1 minus U 1 plus cos pi into U by V1 square. So by substitute all the values, 2 into V1 52.62 minus 24.41, 1 plus cos 20 degrees into 24.41 by V1 square 52.62 whole square. So by calculating this, we obtain 0.9647. So this is the percentage. We need to calculate the efficiency in terms of percentage, that means into 100. So 96.47 percentage symbol.